Hi there, this is exercise 2E for Year 12 Further Maths. We're looking today at what's called the vector product. Product, you remember, is where you times two things together, so the vector product is where we times two vectors together. And this is it here, actually. It's called the vector product, very often called the cross product, because it's got a little time symbol in between, and that looks like a cross. As opposed to, of course, to the A dot B that we saw last time, which was the magnitude of A times by the magnitude of B, times by the angle in between, cos. This was A dot B equals AB cos theta. Now, this, as I say, is the dot product, or the scalar product, is its posh name. And it's called a scalar product because when you multiply these two things together, you end up with a scalar, a number, not a vector, definitely not a number. So the number might be like 2 or 3 or whatever, but definitely not a vector. Whereas A cross B is a vector, and that's why it's called the vector product, or that's why it's called the cross product then. And there is actually a link between this and this. There's a similarity. You notice I've got an angle there. So it's quite interesting that you can end up with something quite interesting out of it. Anyway, let's have a look at this. Before we do this, we're going to have to remind ourselves of how to find the determinant of a 3 by 3 matrix. And we need this because, quite surprisingly, this has got something to do with determinants of 3 by 3 matrices. So let's just remind you what you do if I want to find the determinant of A, usually written like that, or just simply as det A, like that. You do 1 times by the determinant of this matrix. So it's 0, minus 2, 1, 1. And then you could do, it always goes plus, minus, plus, and that. So minus the, interestingly, it's minus a minus 3, but that doesn't matter. Minus a minus 3 times by 2 minus 2, 4, 1. And then we do plus 2 times by, and it's there, 2, 0, 4, 1. So I can work out each little part. It's 1 times by, so I don't need to worry about that. And then I'm just going to do 0 times by 1 is 0, minus 2 times 1 is minus 2. Very easy to go wrong on those. And then plus 3 lots of, what is it? It's 2 minus a minus 8 plus 2 lots of 2 minus nothing. So what's that gives me? That gives me 2 plus 3 lots of, I think that's 10, plus 4. So 34, 36 is what I get as my answer. Now look, bear with me for a moment here. I'm going to do this a slightly different way. Imagine I did det A. Now last time I kind of went across, I used these as coefficients for these matrices. Now this time I'm going to do it slightly differently. So this time I'm going to do it, and just look at this. And I don't think I've shown you this before, but I'm going to go and use these numbers instead. It's a weird thing about determinants. You can do it in a number of different ways. So I'm going to do 1 times by, and then I'm going to use this matrix. So just look at this. 1 times by. My matrix is this time 0, minus 2, 1, 1. Well, actually, I suppose that hasn't changed. And I suppose it was never going to change, because it was the same number. But now, rather than doing this minus a 3 times by, it should be minus this 2. And for this one, it's these 4 numbers. So minus 3, 2 in the top row, and then 1, 1 in the bottom row. And then plus 4 times by. And because that's down there, I'll do these 4 numbers. Minus 3, 2, 0, minus 2. Now, you might think to yourself, well, why on earth is he doing that? Because, you know, obviously, we've already got the answer. But it just highlights the fact that you can do it more than one way. So the first one was the same as last time. This one's minus 3, minus a 2. And this is plus 4 lots of 6, minus nothing. Let's work that out. That's 2 minus 2 lots of, well, what's this? This is minus 5. So that's times 1 minus 2, that's plus 10. And this is 4 sixes is 24. And bizarrely, even though it's a completely different method, we've still got 36. And the good news is the answer is 36. So bear that in mind, because I am going to, in a bit, find the vector product, and this is the rule that we're going to use. Notice it's a determinant of a 3 by 3 matrix. So put it into context. If I've got two vectors, A1, A2, A3, A1, A2, A3, B1, B2, B3, I can find the vector product by putting it into this determinant. And notice the front row is ijk, front column rather is ijk. And then the two vectors go down like that. So copy that down, perhaps pause the video if you need to. I'm going to go on now and have a look at this example. Find the vector product of these two vectors. Well, U cross V then is equal to ijk. And the reason why I do it this way round is simply because this is the order it does it in the formula book. In the textbook it does it like this. I've taken that directly from the textbook. And the formula book is the same, and we might as well get used to it, because then we can always refer to it in the exam. So this equals, and this is the weird thing, you just write I times by this little minus 7, minus 3, 2, minus 2. Now remember it goes plus, minus, plus. So minus j times by 2, 1, 2, minus 2. And then plus k times by, we're down there, so we're at 2, 1, and minus 7, minus 3. So let's do each part of that. And the ijk obviously just refers to the fact that I'm going to end up with a vector. What's the number of i's? So that's 14 minus, and minus 6. Minus j, what have I got? I've got minus 4. Minus 2 plus k minus 6 minus 1 times 7 is, or minus 7 is minus 7. So that's, and at this stage I might as well write it as a vector. 14 plus 6 is 20. That's my I number. Now I've got minus 4 minus 2, that's minus 6, but it's a plus because it's a minus outside, 6. Minus 6 plus 7 effectively is 1. I think that is my vector product. What did I get here? 26, 1. So 26, 1 there, it's worked perfectly. All over the same space, but that's the idea. Now interestingly, this actually gives us, and I kind of hinted this in the original picture, this gives us a perpendicular to both the vectors A and B. So if I find the cross product of U cross V, I get n, and this is coming up here, which is where you can think of this as being two vectors in a plane defined by the two vectors, but at right angles to them. This comes up straight out. This is the perpendicular to it. So just this says find the vector which is perpendicular to both of these. Now on the one hand it doesn't tell me to do so, but this should be a big old clue. We're going to do A cross B, because I know that the vector which is perpendicular to these will be A cross B. So I'm just going to write A cross B equals, put my I, my j, and my k, then do my first vector, 1, 1, minus 2, do my second vector, minus 5, 1, 3. This equals then I times by 1, 1, minus 2, 3, minus j, minus, remember it goes plus, minus, plus. What have I got? I've got these numbers, 1, minus 5, minus 2, and 3. Then I've got plus k. What's that times by? 1 minus 5 and 1, 1. That's quite nice. What's this equal? Well, my I direction, I've got 1 times by 3 is 3, and then minus, I think it's minus and minus 2. Minus my j, what's my j? It's 3, minus, what is it? It's a plus 10. And then I've got a plus of k, and it's 1 minus a minus 5. So again, there's a vector that's 3, that's 5, I would have said, in my I direction. 3 minus 10 is minus 7, but it's minus, so we've got a plus again. And 1 minus a minus 5 is 6. It's a positive 6. 576, there you go. The lines L1 and L2 have equations. Now remember, these are the direction vectors. That's D1 and that's D2. Calculate this by this. Alright, fair enough. I'll just do it. So I'll do it here. At least start it off. It's I, J, K, 3, 4, minus 1, 3, 5, 2. And it equals, I'm going to write it here, I 4 times the 2, which is 8, minus and minus 5. Plus minus plus, so it's a minus j times by 3, 3. So 3, 3, minus 1, 2. So it's 3 2s are 6. I'm regretting not showing all my working out now. Minus 3 minus 1s and minus 3. Plus my k. So it's this top one, it's 3 5s are 15. Minus, and it's 3 4s are 12. Okay, it's not so bad, I suppose. Is it? So I think that is, in the ijk direction, 8 minus minus 5 is 13. The j is 6 minus minus 3, which is 9, but it's minus 9. And 15 minus 12 is 3. So I think that is my perpendicular, sometimes written with an end to show it's a perpendicular vector. Hence find the equation of the line passing through this, which is both perpendicular to both L1 and L2. Alright, so basically I'm going to use the fact that I know that this is the perpendicular vector. And it goes through this. Well, this is the equation of the line. We know that all lines are R equals A plus lambda D, where D is the direction vector. That's what these were. So in this particular case, I'm going to write therefore R equals A. What's my A? It's point on the line. Any point will do. Well, they tell me 1 point. So 1, 5 minus 2. Don't want to make it hard for myself. Plus, now they've used the lambda. They've used a mu. Let's use a different letter. I'm going to use S. And my direction vector is 13 minus 9 and 3. Let's see what the answer is. 13 minus 9 and 3. And they've done exactly. In fact, I use an S as well. Look at that. That's right. So that's it. We're finished. We're going to look perhaps at a couple of examples in class as well. It's a nice little method, and we come back to this in year 13 and practice this quite a lot, because this method starts being really, really useful when you're doing some year 13 further maths vectors. Thank you very much.